everybody. Today I will talk about progressive web apps. Who of you already heard about progressive web apps? Oh, that's nice. How many of you had the luck to work with them? Still. Okay. So today we start still from the basics of progressive web apps. We will see caching strategy. We will see some tools we can use to build them. Then we will see, of course, some practical demos. And at the end, I hope with the last demo to be able to give reason to the title. So offline web application nowadays with modern technologies don't exist anymore. Before starting, just a couple of words about me. My name is Francesco Leardini. And probably, as you already guessed from my accent, I come from Rimini, Romagna. I'm a consultant and Angular trainer at Angular. We are a consulting company, giving a training in Angular and working with a wide range of technologies. So if you're interested, see our website. But let's start. Let's imagine we are traveling, maybe on the train, on a rural area of the city, or in the mountains. We have to cross several galleries, so the connectivity is not really reliable. Or sometimes you just need to be in a hotel, and still, connectivity is not perfect. And still, we are reading maybe a blog, some articles, and then when we switch from one article to the next, this is what we get. So just a donut, or so-called, at least if you use Chrome. And but this now belongs to the past. Nowadays, with the modern web technologies, with modern websites, we can provide a better experience to our users. On one side, as a minimum, we can provide an offline page with a branded logo and colors of the company, eventually also some static data like a phone number or email address. On the other side, there are some companies that move even a step forward. For example, Trivago, if you access the website and you are offline, allows you to play a labyrinth game. So this is a quite interesting idea because the attention of the user is kept on the application, so that hopefully your connectivity will be soon after restored, and then you are already on the website. So Trivago, with this little game, would not lose a potential customer. In the last years, the gap between progressive web apps and native apps get shorter and shorter. There is a very cool website called whatwebcando.today that summarizes all the APIs available through the browser. Of course, these are mainly for modern websites, so I'm sorry to say that EA11 is not among the group. But those APIs are really cool, are really powerful. For example, with the vibration API, we can interact just via the browser. We can interact with the user device. We can, for example, by clicking a button, we can decide for how long should the user's device vibrate, for example. And this just a few years ago was just like dreaming. Another interesting website is called PWAs.com. It collects all benefit or successful stories of companies that adopted PWA for their business. And if you go and access the website, you can see how and in which measure those companies benefit from adopting a PWA for their websites and in their business. But that's it. Let's go a little bit more technical now. What is a progressive web app? Progressive web app is nothing else than a web application that, by using modern web capabilities, aim to give a user a richer experience, an experience that is much closer to a native app. There are some basic functionalities that a progressive web app must give or provide. One of them is that it must be installable on the user device. This can be done with the web app manifest. We will shortly see what it is. Can work even offline via service workers, can send a push notification to increase re-engagement of the user. For example, we have a blog or e-shop with clothes, and when we have a new collection, we can send a push notification that will be sent even if the user doesn't have the browser open or our app open. This will be sent in the background and still be available on reaching the user device. And at last, but still very important, progressive web apps must be responsive, so they have to fit and in a good way on any kind of device and resolution. So not only desktop, but also mobile, tablet, and you call it. Let's see how can we install a progressive web app on a user device. This can be done by setting up and properly instantiate a web app manifest that is nothing else than a JSON file. There are a set of mandatory properties we have to initialize. Let's start seeing them. We have to provide a name and a short name that will be used in the splash screen of the application and below the icon once it will be installed on the user's device. We can provide a display property where we can instruct the browser how should render our application. There are different values. Browser is a normal standard browser experience, so as we would access any kind of website with our browser. Standalone is already more interesting. We see we don't have anymore some of the UI elements of the browser. For example, the URL bar is not there anymore. And with a standalone display, the application will be open in an independent window and not in the Chrome one or the browser one. So it will look even more as a real native app. Last, full screen is best suited for games or media content. It will take, as the name says, the full screen of the device. So there are no at all browser icons or anything else. We have to provide the start URL, the beginning of our website. This is because we don't want that if the user visited some pages and then close the app, the next time it will be opened or redirected to that last page he visited. We want that our app opens always on the home page, indeed, as a native app. We have to provide a set of icons. As a minimum, we have to provide one icon of resolution of 144 pixels. Here we have two. These are the Chrome requirements. It has to be at least 192 and another one 512 pixels resolution. Then Chrome will take care for us to scale those images according to the user device. Of course, if we want to provide a pixel-perfect experience for our users, we have to identify which are the targets, devices that we want to address to, and then provide a specific resolution in this array. But this is, let's say, the minimum base we have to provide. If all those properties are instantiated and initialized in a correct way, when the user will access our website, again, via the first time at least via normal browser, he will be prompted whether he wants to install on the home screen our application. If he cancels it, this dialog won't appear for at least 90 days, not anymore. But, and let's hope it's the case, if we click on Add, then the application will be installed on a user device. And we can see that the look and feel is really exactly like a native app. From that moment on, the user just have to click on the icon and it will be redirected through a splash screen to our application. So this was how to install on a user device our website. But we see that also we have to provide the progressive web apps as to be available even offline. And this we saw is possible through service workers. Service workers are just JavaScript component acting as a proxy between our application and the network. They are able to cache all HTTP requests and assets, but we have to define and to specify how, because the service worker out of the box won't cache anything for us. It's important to note that there is no blocking, and this by design. Service worker runs on a separate thread from the one used from our application. And this is what we want, because we don't want that if the service worker crashes or if he's executed in the background a very heavy job, this will affect at all the performance of our web application. And also it's important to note is that it works only on secure connections. So we can use HTTPS, otherwise we will see that the service worker won't be installed at all on our browser. Angular, in the specific, provides two strategies to cache HTTP requests and data that we require. By default, it is using a performance performance optimization strategy. This means that we want to provide the response as soon as possible. So we go first to the cache, and then only if the requested resource is not available in the cache, then we will try to fetch it from the network. On the other side, we have also freshness caching strategy. As the name suggests, we go first to the network. We want to provide the latest data. We can think about maybe an application that provides stock exchange rates, so we want really the last values available. But then we can define a timeout, and if the response doesn't come within the defined timeout, then we go and try to provide the data from the cache, of course, if available. With this strategy, we will benefit users that are online, but on the other side, we have some old data for the users that are offline because we provide it from the cache and maybe not really the latest. So Angular provides only these two caching strategies, but aside those, within the service workers environment, there are others. One of them is called the stale while revalidate strategy. And it works like this, that first we try to provide the requested resources from the cache. So we try to provide the response as soon as possible. But then in the meantime and in the background, we go and we fetch in the network a newer version of the requested data, of course, if available. And then we store in the cache. So that, if this data then is available, will be refreshed and updated in the cache and provided next time. So that said, let's see some tools we can use to create and will make the job of creating a progressive web app easier for us. The first of them is a Progressive Web App Builder. It's an open source project delivered by Microsoft. It's in the newer version that completely renew the layout and the feature set. It works like a website, or we can download it locally. As a website, we can provide an URL, for example, of our application. And then the website will analyze our portal, our website, trying to identify whether a web app manifest is existing, a service worker is existing, and whether we provide a secure connection. According to this parameter, we'll give a point from 0 to 100. In this case, just 20, because either a manifest and a service worker are completely missing. But so we can use the manifest and service worker tab provided by the application, and this will try to create a skeleton for us and fill some of the data that can fetch from or scrape from the website for us. The service worker tab is interesting because we can, resolution is the best, we can choose different strategies, and according to the strategy we chose, for example, offline page or cache-first network, the portal provides already a code snippet that we can simply copy and paste on our portal. So actually makes a big step already for us. What we have to do is just define more or less what we need, copy-paste, and we are good to go for our web application. Another tool is called Wordbox, this time provided by Google. Wordbox is a set of libraries and node modules that wrap and abstract the complexity of progressive web app, service workers, and caching strategies. It works by defining routes, and via route we can define and target specific assets. For example, we are interested in caching. And then by simply calling a method, we can define or choose which strategy do we want to use. Stale while revalidate is the third strategy we just previously saw. On the other side, we can not only target which assets, in this case images, we want to cache, but we can also provide for how long and how many items do we want to keep in the cache. Those two tools are framework agnostic, so they don't interact specifically with any specific framework. We can use it for Angular, vanilla JavaScript, React, as you want. But since we are here to hear something about Angular, Angular also provides, since version 1.6 of the CLI, through schematics, a way to inject the progressive web app capabilities to an existing web application, Angular application. So now we are already very well and very proficient with schematics after Thomas' talk, so we have no worries about that. What is important to note with this command is that the service worker module will be installed and registered for us in the application. Furthermore, a web app manifest with default values will be created and a file called ngsw-config.json. This is, for us, is the Angular service worker configuration file. There we can define all our strategies and asset targets. But let's see first now a basic demo, and we see a little more in detail those things. The demo will show is a very basic Angular application. I just created it via ng-new command and removed the logo of Angular with the angularday logo, but nothing else. With that, I then encode the schematics to add progressive web app capabilities, and that's it. The goal of this demo is to show with very, very little effort how can achieve already a working progressive web app application with Angular. Okay. Should be enough readable. Good. So this is what Angular creates with the ng-add Angular progressive web app, or PWA command. We can see that we have an Angular service worker configuration file where we have one object or one array of objects called asset groups. There, by default, we have two objects, one named app and one named assets. It's important the app with install mode prefetch, these will target our core version, our core application that we want to provide. This is the minimum set of static assets we want to provide. This is our app shell. Install mode prefetch means that while the service worker is downloading and is installing in the user browser, it has to prefetch those kind of assets and save them in the cache. The goal is that once the service worker is installed, then he has to find already those assets in the cache. If this prefetching step fails, then the whole installation step of the service worker will be aborted, and we won't have any service worker installed. Of course, if the user then accesses again or refresh the page, there will be again a new retrial, and the service worker will try to prefetch this data. On the other side, we have another group named assets. These are files we can target in the assets folder, or image or fonts, for example. We don't want to prefetch those, but we want to gather them only once requested, at least once. And this is the reason of install mode lazy. That means, okay, get those requested data asset, but only if they are requested once. So we can define an update mode prefetch. And this means once we have these resources cached in the cache, we can try and fetch or try to see if there is a new version of those on the server. And if so, it will eagerly download and update them. We can use also lazy. In that case, it will not download eagerly those resources if new on the server, but only if newly requested. So these groups, this setup is out of the box by default, but we can even define caching strategy for API requests. And this goes a bit more interesting. So in this case, we have to define data groups array. And here we can define objects. The name, it doesn't matter. Now for clarity, I called one performance strategy and the other one freshness strategy. In here, we will see how can we implement the two Angular caching strategies for data requests. We can define an URL. So we want to target, for example, all the translations And so we want to cache them with a strategy performance. So performance optimization means that, okay, we get them, but then we also try to give them always from the cache, because we think, okay, translations from our website should not change so often. So it's not so important that we always try to gather the last one, the last values. We can define for how long we want to keep in the cache, in this case 3 days, and how many requests or responses we want to keep in the cache. On the other side, we can imagine we have a website blog and we want to provide our users always the latest articles, the latest blogs that are being published. And because of this, we can define another API with the strategy freshness. With this, every time the user tried or will access this API, we'll always get, if online, we always get the latest and greatest articles. But then we can define a timeout, in this case 5 seconds. And if this timeout is triggered, then we will try to give the blogs from the cache. So at least the user, even though not the latest, will still be available, possible to access the articles that were being previously cached. So we have seen it's quite simple. Okay. Now, we have seen with so small effort, we can achieve already this result. Yeah, too many. This result. Maybe 10 minutes work, maybe 15, and we are already good to go. It's nice, we can cache those requests and so on, but the important things to note is that we can cache only GET request. Cache API that is used by the service worker doesn't allow, at least yet, to cache any POST request. So we can provide just data that is requested, but we cannot provide any possibility to use a full set of CRUD operations. If we want to go a bit further, we have to implement some custom solution. For example, a solution that uses IndexedDB. We gather the API request, POST, for example, there, and then once we are online again, we collect those IndexedDB and we try to re-execute them in the correct order. It's not too complicated, but something that we have to do. But of course, with all the set of technology we are available nowadays, how can we do better? With less effort, how can we, for example, provide a full offline experience to our users? Not only get and reading data offline, but also let them work while offline on our data. And this is possible. How many of you know Firebase? Great. Then I won't tell much about it. Firebase is similar to Azure, is a platform that provides a set of functions and services targeted especially for web development and mobile, iOS and Android. Some of the functionalities or services provided are only for the mobile, for example, and clearly, Crashlytics or A/B testing, but others are also available for web development. We will see the benefit that we can get in the specific case from Cloud Firestore. Cloud Firestore is a NoSQL database that since the beginning of the year came out from the beta release. So now is officially in a stable release. It's really cool because it provides a really interesting set of functionality, and other than that, is very good in scaling. One of the functionality that we will focus on is called the three-way binding. Three-way binding works like this. We have a client connected to the server and to the database, Cloud Firestore, that is hosted in Firebase. Client A changes some documents, saves them, and those are saved on the database. The database, Cloud Firestore, will take care for us to propagate automatically those changes to the client C, B, and so on. So those clients that are connected will see and will receive those newly updated documents without having to do any kind of active polling or any page refresh. This is done via sockets and observables. Another very interesting functionality is offline support. Offline support was introduced not only for mobile, but also for the web with Cloud Firestore. And to activate in our web application is quite easy. We just have to call one method called enable persistence. That's it. We have to do for web application explicitly, while for mobile development, this is already active on default. Once we invoke this method, Cloud Firestore will start caching locally all the documents that you receive from the server. There is a threshold or a cache limit of 40 megabytes by default, but we are free to define our own limit or change the values. If this cache limit is reached, then Cloud Firestore will go through the cache and delete all the old documents in order to bring again the cache documents within the predefined limit. Once we have all those documents available locally, we can not only access them, but we can change, delete, and do whatever we want with those. Once then we restore our connectivity, Cloud Firestore will detect this and will, for us, take all these pending changes and synchronize automatically with the server. So for us or for our users, this whole process will be done completely transparently. So the user will not have really perception to be offline or online. So we have to mention that there are some limitations in that. The first one, and by design, we can have maximum of 500 offline transactions. This was by design because this kind of functionality is not meant to be used in a longer range of time, for weeks, but only for short time when we don't have a connectivity available. And another important limitation is that a last write wins logic is used, so that if we have multiple clients offline that synchronize their own pending changes, we cannot ensure that the changes will follow the real chronological order once they reach the database or the server. Of course, to mitigate this, we can implement our own custom behavior. For example, Firebase provides cloud functions. Cloud functions are Node.js piece of code that we can store on Firebase, and we can say how to trigger them. So for example, every time there is an update on our database, we can trigger our snippet of code and try to maybe put on the queue all those pending changes and try with the timestamp to reconstruct chronologically the real order before wiping the cache, the queue, and pushing to the database those changes. But as to be mentioned, and this doesn't come for free, we have to implement. We have to put some effort in that. Good. Now let's see something more interesting, a bit more interesting demo. It's a project that I implement for myself for personal reasons. It uses Angular and progressive web app capabilities with the command we saw before, uses Cloud Firestore as a NoSQL database, and the application itself is stored in Firestore. Actually, I forgot the first demo. Yeah, we can quickly do it. So the first demo was that we have this very simple Angular application. As I said before, just the ng-add, PWA add, that's it. And we can see that if we open the Chrome DevTools on the application tab, we have a service worker installed. So now the interesting thing is that if I go offline and I refresh the page, I can see that the data is still correctly given because we have the service worker that it was installed and can provide cached data. If I unregister it, and we can see now the service worker is deleted, so we don't have anymore a service worker locally running. Now, if I refresh the page, voila, we have our friend dinosaur again. So this to demonstrate that indeed the service worker is has to be installed and is easy to use. As a last thing, I'm using for localhost. We can see we are localhost. I'm using a web server from Chrome. You can use HTTP server. That's because we cannot use service worker with ng-serve if we want to test them locally. We have to use an HTTP server because ng-server doesn't work. Good. Let's now with the other demo. I will open 3 windows in order to simulate 3 clients. And I will also mirror my mobile phone. On the phone is the same app installed. Again, is a progressive web app, is installed, and we can see that it looks, as we saw before, looks exactly as a native app. Using display standalone, we saw that we have an independent window. This is what I mean, that we have a Chrome, but our progressive web app, even though is a web application still, is given and served in a complete independent window. So it looks indeed as a native app. Actually, to this point, we cannot even say if it's a native app or not. Another important aspect we saw at the beginning, progressive web app must be reactive. So we can see how in the mobile view we have only the records or the documents with only one column, and we have icons with no text. While on the desktop version, let's call, so the left and the right part, we have icons and text. Of course, being on the desktop, I can resize my window, and then the application flawlessly and very smoothly will adapt to the given space. So here on the left side, I have the application running locally. In the middle, I'm mirroring my phone, so the application is installed locally. On the right side, I'm connecting to the same application, but is hosted on Firebase. Now, let's see what is the 3-way binding. I can take one record. The domain of this application is that during my travels, I keep track of nice bars and restaurants, so I can suggest to my friends, or actually I can suggest to not visit if they were not really good. So just a very simple application with some data and comments and rates I can give, or Google rates I can get. So now, if I change that, and maybe I write online and change the name, we can see that immediately once it's saved, the same change is propagated to the other clients. So on my phone, I have it online, and on the server version, I have it online again. I take now the server version, change it again similarly online, save it, and that's it. In 1 second is propagated to the other clients. We don't have to do any refresh, we don't have to do anything. With observables, we get this automatically. But now comes the very, very cool thing. I go now offline with my mobile, so I switch on offline mode, airplane mode. I go back, and we can see that I have the airplane mode on the top right. So here, though, I can still access my data. I can pick up a document that we didn't open before. So I can click on details, and I can see I have all the details, even though I didn't open them before. Now I can write offline, for example, save it, and then I can see that on my phone I have that document offline, but on the others there is nothing, because the other 2 clients, of course, they are online, and I'm traveling somewhere, or I'm attending some conference, and I don't have internet. So I can change even another one that we touched before. So I remove, for example, online from the bar that we saw before, save it again, and voila. We have now 2 documents that we changed offline only, and the other 2 clients absolutely untouched. Now, I switch off the airplane mode, so I will reconnect with the network again, and what I would expect is that Cloud Firestore will detect my pending changes and magically, let's say for us, will propagate those pending changes on the database, and the database will propagate to the other 2 clients. Let's see. So I turn on the Wi-Fi again. I don't touch anything, and hopefully the Wi-Fi will get faster, and we can see this is actually why by on chose, so to give some thrill, a bit of delay. Yeah, so what we will expect as soon as now it will detect the connectivity. Yeah, we are connected. It might take some time, but yeah, it will come, believe me. So those two changes, we would expect that they will be updated to the other two clients. Actually, I'm using a Cesare phone as a hotspot. He was very kind to provide. Hola. So with that, I hope I could convince you that indeed, with not actually so much efforts, we can provide a solution for our website, for our users that works seamlessly, offline or online. The users won't have any perception of being offline. And then once they get again connectivity, those will be propagated and we are synchronized again. So actually, this was all for my talk. Of course, I will be all the day long, so if you have any questions in the afternoon or whatever, just come and approach me and talk to me. Please also, if you have time, just leave some feedback. It's always good to get critics or constructive suggestions. I have also some T-shirts, like this one. I don't know whether any of you would like to have. Good. Then I can blindly throw away. Sorry. Thank you.